is below that plane, so AY is negative. So now we have the velocity and acceleration along x and y direction. Again, note that x direction is along the plane and y direction is perpendicular to the plane. So as we have already seen, ux is u cos beta, ax is minus g sin alpha. Similarly, uy is u sin beta and ay is minus g cos alpha. Now let's try to find out the range and time of flight of the projectile on an inclined plane. So to do this, first we'll try to write the equation of motion along x and y axis. So as we have seen, the motion along x-axis will be given as x is equal to ut plus half at square, and u is the initial velocity along x direction, which is u cos beta. So we'll have x is equal to u cos beta into t plus half at square, where a is the acceleration along x direction, which is minus g sin alpha. So we'll have x is equal to u cos beta into t minus half g sin alpha into t square. Similarly, motion along y-axis can be given as y is equal to u sin beta into t minus half g cos alpha into t square. So first let's calculate the time of flight. So at the end of flight, the displacement along y direction is 0 because the projectile has touched the ground. So putting y is equal to 0 in this equation, we'll get 0 is equal to u sin beta into t minus half g cos alpha t square, or 2u sin beta by g cos alpha is equal to t. So this is our time of flight. So let's denote it by capital T. So time of flight is coming as 2u sin beta by g cos alpha. Now let's try to find out the range of the projectile along the inclined plane. So this is our range along the inclined plane. It is nothing but the displacement of the projectile along the inclined plane, that is along the x direction. So r will be given as uxt plus half axt square, and here t is nothing but time of flight, that is t, which is equal to 2u sin beta by g cos alpha. Now here ux is u cos beta and ax is minus g sin alpha. So now let's carry out this calculation. So we have r as uxt plus half axt square, where t is time of flight, that is 2u sin beta by g cos alpha. Ux is u cos beta and ax is minus g sin alpha. So let's put these values in this equation. So r will be equal to u cos beta into 2u sin beta by g cos alpha minus half g sin alpha into t square, that is 4u square sin square beta by g square cos square alpha. So we can cancel out 1g here. Now making the denominator of these two terms common, we'll get 2g cos square alpha, and in the numerator we'll have to multiply this numerator with 2 into cos alpha, so we'll get 2 cos alpha into u cos beta into 2u sin beta minus 4u square sin alpha into sin beta, which is equal to, again we can take 4 sin beta common in the numerator, so